Our next section is section 4.7, and it is going to focus on the quadratic formula, which you should already have a decent amount of experience with the quadratic formula from Algebra 1. So I'm hoping that most of what I'm talking to you about with this will be a review. So the quadratic formula I do have listed. It is a formula that you should be very comfortable using. It is not something that you should ever have to worry about memorizing. You definitely should have it written down in your notebook somewhere kind of prominent in this particular topic so that every time we're being asked to use the quadratic formula to solve, you have it ready to go. Quadratic formula is specific to solving any sort of quadratic equation. The key to start, though, is it does have to be in standard form. Just like same thing when we go to factor, we kind of start with standard form as our go-to. Once we have it in standard form, we then figure out our a values, our b value, and our c value. A is going to be how many x squareds, b is going to be how many x's, and c is going to be your constant. I usually make a list and put it off to the side. And then essentially you're just plugging it all into the formula. It is kind of a long formula. I will say that of all the different techniques we've talked about with solving, this is probably your last resort. I think factoring is one that you should try first. I think square roots is one you should try. But if those don't work, then quadratic formula is kind of like your backup plan, is the best way to think of it. So rather than jump right into the formula, I want this video to focus on something called the discriminant. So if you look at the formula, and it is pretty long, the discriminant is specifically the part that is under the square root. So this is your discriminant. And the key with the discriminant is what its value is will give you an indication of how many answers you're going to get and how many real answers you're going to get. So I'm going to kind of jump ahead and have this video really focus on just that one part of the quadratic formula. So we're going to go here. So the discriminant, again, you want to make sure you have the formula written in your notes. Your discriminant is just the part under the radical. It does not include the radical. So the discriminant is the part that is the b squared minus 4ac part of the quadratic formula. And here's the key to the discriminant. Depending on its sign, positive versus negative, we can tell how many solutions, and we can also tell what it looks like visually. So I want to go through this chart and kind of show you why the discriminant is such an important part of the quadratic formula. So if my discriminant is positive, so if I do the b squared minus 4ac and I get something that is bigger than 0, what that means is I will have two solutions, and they are both what's called real solutions. What this means visually is it's going to cross the x-axis twice. So you can think of it as something like this, where you have an x-intercept here and an x-intercept here. Anything that has a positive discriminant will look like that, where you have two places where it crosses the x-axis, giving you those two real solutions. If you have a discriminant that actually equals 0, so you go through the whole process, b squared minus 4ac, and you get a 0, what that means is it only has one real solution, which means instead of crossing the x-axis twice, it's just going to basically sit on the x-axis. So this one, I'll kind of draw you a couple pictures. This is going to be one where when you draw your parabola, it's going to just touch your x-axis. Or it can be drawn flipped upside down, and it's going to just touch. I didn't draw it very wonderfully, but it has that one point, that vertex is going to be right on the axis. So you're going to have, let me try to like fill this in. So you're going to have that vertex point, doesn't want to fill it in for me, that is your x-intercept. So your vertex ends up being your x-intercept, and it's the only place where it will ever touch the x-axis. And then your last option is that you get your discriminant, b squared minus 4ac, and you get a negative value. You get something that is less than 0. If this happens, we get no real solutions. We actually have what's called two imaginary roots. What this looks like is it will never touch the x-axis. It will never cross the x-axis. These are the ones that I often describe as like floating parabolas. They're floating above the x-axis, or they could be floating down below the x-axis, but they never come in contact with the x-axis at all. So that's the key to the discriminant. If we know what the discriminant is, we have an idea of what type of answers we're looking for. So if you look at these ones on the bottom and it wants to know what the discriminant is and how many solutions will it have. So I'm going to write down my a, b, and c. A is 1 because there's 1x squared, b is negative 6, c is 8. So I'm going to do b squared minus 4ac. One thing to notice, when you square a negative number, you're going to get a positive. So I like to tell students, forget about putting the negative in and just do positive 6 squared minus 4 times a times c. And again, what that does is it saves any issues with parentheses and saves any mistakes plugging in your calculator. So 6 squared, you could grab your calculator, minus 4 times 1 times 8 is 4. Since I have a positive discriminant, that tells me that I have two real solutions, meaning it's going to cross the x-axis twice. Next one, a is 1, b again is -6, c is 9 this time. So b squared, again, I'm not even going to include the negative, so I'm just going to do 6 squared minus 4 times 1 times 9. I end up getting 36 minus 36, which is 0. And what this means is it only has one real solution, which means it's only going to touch the x-axis right there at the vertex. The vertex is going to touch the x-axis. And then finally, my last one, a is still 1, b is still -6. This time c is 10. So b squared, 6 squared is 36, minus 4 times 1 times 10, which is going to be 36 minus 40, which is -4. Since I have a negative discriminant, this means that I only have imaginary roots. So I'm just going to write 2 imaginary, meaning it will never touch the x-axis, never cross. So if I were to graph this on my calculator, I would notice that it never crosses or touches the x-axis. So if you more, again, the same thing, you're going to have questions where all it's going to want is the discriminant, or to use the discriminant to tell you about how many solutions. I'm going to add 3. This one was not in standard form. So a is 1, b is 2, c is 3. You can do a lot of this on your calculator. So if you want b squared, you can just type in 2 squared minus 4 times a is 1 times c is 3. You get a -8 discriminant, meaning that you will have only imaginary solutions, no real solutions, meaning it will never cross the x-axis. Next one, a is -1, b is +3, c is 4. So b squared, again, you can use a calculator, b squared, 3 squared, minus 4 times a is -1 times c is 4. We get 25. What that tells me is it has 2 real solutions, meaning it will cross the x-axis twice. And then the last one is not in standard form. I'm going to bring everything to the left just out of habit. You could go the other way if you'd like. So I'm going to subtract 4x. I'm going to add 4. A is 1. B is -4. C is 4. I want to show you on the calculator because I keep talking about the calculator and I haven't mentioned yet. If I were to graph this, so once I have it in standard form, if I just want to graph x squared minus 4x plus 4, and I hit graph. Oh, I got to change my window. 1 second. So zoom 6. And you can actually see visually what you expect to happen. So what I notice visually is instead of crossing the x-axis, this one just kind of sits on the x-axis. So I expect that when I do b squared minus 4ac, so b squared minus 4ac, notice I didn't put the negative when I squared it. I'm just going to do 4 squared minus 4 times 1 times 4, which is 0, which means it has one real solution. So you can use the picture to help you so much. If you were to graph this one, I'll show you that one and then we'll be done with this. If you go to y equals and you type in the middle equation, so -x squared plus 3x plus 4, and you graph it, you should see it cross the x-axis twice. So right away, my discriminant answer should confirm what you see from my picture. And that's how we use the discriminant part of the quadratic formula.